Hi there, welcome to the step-by-step crystal video series. Today I'm your host Ekrem. I'm gonna talking about the loops in the crystal language. In short, loops are data structures or a thing that are used to execute the same code block or following code block for specified number of times. It can be once, or twice, 3 times, or 4 times, or more, or maybe none. Let's see by the examples. Today I have created a file named loops.cr. First type of data loop is a while loop. Let's see, we have a while loop that we have a iterator. Let's define iterator first to 0. In this example I would like to print the numbers from 0 to 10 while we define while iterator is less than equal to 10 because we want to print it to up to 10. Iterator, or you could name it I, and iterator increment it one by one and then end. Let's save it, open a new window, of course, and run it. Loops.cr. Yeah, from 0 to 10, one by one numbers were printed with puts, as you can see. You could write this example like, for example, deleting the iterator, giving one more parenthesis, plus equal 1, and puts it, save it, and run it. Yeah, but this time it begins from this 1 because first incremented it, then the output it the result. If we were to do like from 1, we would do the previous example like so. Okay, let's continue with the until loop. Remember that the while runs its code block while when the condition is true. In this example, iterator is first 0, it's less than 10 and equal to 10, and then when you increment it, like previous example, y1, when you increment it first, it becomes 1 still less than equal to 10. Iterate it, or sorry, increment it by 1 again until it equals to 11. It becomes false. While it's false, this code block won't run. They won't run. While it's true, it runs. But there is opposite of while. We call it until. We could change it. Until, when it's true, when it's false, it runs its code block. In this example, iterator while less than greater than 10, in the previous example less than equal to, in the same code, to get the same result, we could write it with this one. Until iterator become greater than 10, it will run. You could think as it. Let's save it and then run it. Yeah, as you can see, from 0 to 10 all numbers are respectively printed. You can think about the opposite one of the while, or as to until, to while, opposite of until. There is also times word. Let's clean that and write another example. Sorry. Times are run specified times like the other ones. For example, 10 times. Sorry. Do. In this example, we use do. Pay attention to this point. And iterator. At this time, I put I. It will begin from 0. If I'm not wrong. Let's see. Put I. And save it. Run it. Yeah. Up to 10, not 10 actually printed, but it prints the operator 10 times. Or otherwise we would use 11 times. From 0 to 10 it becomes 11 numbers. From 0 to 9 there are 10 numbers, 10 natural numbers from 0 to 9 to count from 0, 1, 2, 3. The 10th number is 9. Yeah. After times there are up to, down to, sorry, up to and down to as well. They are like you assign a beginning point like 1, then point up to, which increments and reaches to 10. 1 is beginning point, 10 is the ending point. Do operator as well. I, our iterator. Same code I've write. It will exactly write the outputs, the numbers from 1 to 10. Yeah, it would be very clear to define what you need, what you do if you print to 1 to 10. You could write like so. There is opposite one down to. In up to there is an increment subject to, and decrement. In down to there is decrement. Decrement from, for example, 10 to 1. Then we change it, not replace, down to. This example, it would print numbers from 10 to 1. Let's compile it. Yeah, from 10 to 1 our numbers are printed, our output. Here are our results. And then the last one are each. There's a each method. It's a enumerable thing, but we also use for the as a loop. Remember, we see ranges in the data types series, data types part of our series, from 1 to 10, including 10, point each, EACH, do I, not SH, puts I, and save it, run it again. Yeah, from 1 to 10 it's printed. You would do the opposite one as well, from 10 to 1. But this time, let's for each number we multiply with 2. We go for a different one, and then it would be better if we do with parentheses. Parentheses would be better. Oops. It seems it's only work for increment 1, not increment, by the way I learned. 1 to 10. Beginning point should be less than the ending point. If we run again, yeah, from 2 to 20, incremented by 2, the counting by increment by 2, 2, 4, 6, 8, and here we learned that from 1 to 10 it should be incremented, not decremented 1. And so that's all for our video series. Here are the examples of loops you can use your own as you need it. Thanks for watching, and see you next time.